Hey students, I'm on page 26 now. This is lesson 7.2b. In this one, we're going to learn how to solve inequalities that have absolute values. We're going to start by just reviewing how you solve absolute value equations, and then we'll work into inequalities. But remember, the definition of absolute value means the distance. So if I write this, this means the distance from x to the origin, which is 0 on a number line. So when I solve this equation right here, absolute value of x plus 3 equals 7, first thing I'm going to do is isolate the absolute value. You always want to do that. So now I get the absolute value of x equals 4. Now what that means is what numbers are 4 units from 0? Well, you could be 4 units to the right of 0, which would give you 4. Or you could be 4 units to the left of 0, which is -4. So you represent that by writing two equations. X equals -4 and x equals 4. All right, go ahead, you try that. All right, so to solve an equation in the form the absolute value of A equals B, where A is a variable expression, what you need to do is solve A equals B, and also A equals the opposite of B, or -B. So to solve the absolute value of B equals 3, you solve both B equals -3 and B equals +3. To solve the absolute value of the quantity x minus 5 equals 6, solve x minus 5 equals -6 and x minus 5 equals 6. To solve the absolute value of the quantity h plus 7 equals 2h, solve h plus 7 equals -2h and h plus 7 equals 2h. So we're writing two equations every time we have an absolute value that's solvable. All right, so your cousin was standing on a parade route when she spotted a float 250 feet from her. The parade was traveling at 158 feet per minute. The distance d from your cousin in feet after t minutes is given by d equals the absolute value of the quantity 750 minus 158t. At what times is the float 200 feet from your cousin? Round to the nearest 10th. Okay, since there's two places where it can be 200 feet from your cousin, both before it gets to her and after it's going away from her. That's why we're using an absolute value here. So let's just substitute the 250 in for the d. And so we're going to solve this. Now remember, the definition of the absolute value is that it's the distance to 0 on a number line. So, and that kind of makes sense for this problem. It's the distance from her. Well, the distance from her could be minus 200 feet. That would be before it gets to her. So that's this equation we need to solve. And then it could be 200 feet after her. So that would be the positive 200 feet. Okay, so we're going to solve both those equations. And in both cases, we're going to subtract 750 from both sides. And we get -950 here equals -158t. Dividing by -158 gives us a positive number, which makes sense. And remember, this is a time. So that it comes to be a little bit more than 6. So approximately that time. And the other equation, when we solve it, we get subtracting 750 again from here gives us -550. And we're going to divide by -158. And that gives us about a positive number because we're dividing two negatives, about 3.48 seconds is our t there. So it says round to the nearest 10th. So we're going to say our time is, so this is time before it gets her to her is about 6 seconds. 6.0 rounded to the nearest tenth, and this one is 3.48. 5 rounded to the nearest tenths. All right, go ahead, you try that. Now, sometimes you can solve an absolute equation and it won't have a solution. And that's because the absolute value of number will always be a positive number. So if you're trying to get it to be a negative number, it's just not going to work. And you'll find that in this one. If we try to isolate the absolute value here by subtracting 6 from both sides, we get 5 times the absolute value of the quantity 3x minus 1 equals -3, and dividing both sides by 5, we get the absolute value isolated and equal to -0.6. Well, right there, no matter what's in here, when we do the absolute value, it's going to be positive, so there's no way we'll ever get -0.6. So we're going to say there is no solution in this case. All right, go ahead and try one like that. Okay, here's a concept. When solving absolute value inequalities, solving an inequality of the form less than b, what we're going to do is get, and just think about this for a second. So let's say we're on a number line and our absolute value is the distance from the number line. Well, let's say we want the absolute value to be less than 5. We want to be the absolute value less than 5. So what that means is we need to be less than 5 units from 0. Well, that's going to give us anything in this range. And that's what this part is telling us here. Now, if we say it's greater than, absolute value is greater than 5, what we're saying is the distance is more than 5 units from 0. So again, here's 0, here's 5, here's -5. To be more than 5 units from 0, that would be talking about out here or over here. And that's what this second part is talking about. Okay, we'll get into, go ahead and see if you can figure out 21 and 22 from what I was talking about, and then we'll get into the problem and I'll explain it a little more. All right, so here's the problem. Now we want the solutions to be greater than or equal to 20. So again, what I was talking about, to be greater than or equal to 20 units from 0, that puts you either over here or down here. Well, down here is less than -20. It could equal here also, according to this. And down here is greater than or equal to 20. So we're going to write two inequalities. We're going to write 5x is less than or equal to -20, or 5x is greater than or equal to 20. And then I'm going to divide both sides by 5, and I'm going to find that x is less than or equal to -4, or dividing by 5, I get x is greater than or equal to +4. So on a number line, what I end up with is numbers down here. Since it can equal, we need to fill that in, and then going this way. And then numbers down here, and going this way, since it's greater than or equal to 4. All right, go ahead and try that. All right, here's your solutions. Check those. And we're going to do, this is a situation where it's a less than problem. What we're going to do is let t be the time in the race. And then you can think about this for a moment, but if we want to, it says the athlete wants to run within 6 seconds of his normal time. What is the range of allowable times for the athlete? Well, if he's 6 seconds less, or up to 6 seconds less than the time, so the time is less, we'll let t represent the time. Then that's going to be a positive number. But if he's 6 seconds over that time, and when we subtract this time from 224, we would actually have a negative number. Now to fix that, we're just going to use absolute values because that will turn any negative difference into a positive number. And the times he wants to be less than or equal to 6 seconds. And then to solve that, what we're going to do is, now to be less than or equal to 6, so think on a number line. Here's 0. To be less than 6 units from 0, you need to be somewhere between here and here. All those spots are less than 6 units from 0. So to write this out, we're going to put -6, and this is called the compound inequality. We want our time difference, 224 minus t, to be between -6 and 6. So what we're saying is this is either greater than or equal to -6 and at the same time is less than 6. Now to solve that, we're going to subtract 224, and we can actually do this all at once because it's just really two separate inequalities. But so let's subtract 224 from the 3 parts of this. And that gives us -230 is less than or equal to -t, which is less than or equal to -218. And to get rid of this negative, we're just going to divide by -1. Now when we divide by negative, the signs change. So we get 230 is greater than or equal to t is greater than or equal to 218. So we can see that our range of times need to be between 218 and 230 according to this. All right, you try that. All right, that's it for this video. We'll do some more problems in class the next time we meet.